4 astronauts, 1 spacecraft, 250,000 miles of empty space between them and home. For the first time in over 50 years, human beings traveled to the moon, and this time, one of them had never been there before. Not just as an individual, as a representation of an entirely new chapter in human history. This is Artemis II, and what happened during those 10 days changed everything we thought we knew about returning to deep space. In this video, you're going to learn exactly what the Artemis II mission accomplished, from the precise orbital mechanics that took 4 astronauts around the moon, to the critical life support data NASA collected that will determine whether humans can survive the journey to Mars. You'll understand why this mission was far more dangerous than Apollo, what the crew experienced that no human had felt since 1972, and the single moment during the mission that had flight controllers holding their breath. Stay with this until the end, because the final revelation about what Artemis II discovered is something most people haven't heard. On the launch pad at Kennedy Space Center, Orion sat atop the most powerful rocket ever successfully flown, the Space Launch System, generating 8.8 million pounds of thrust at liftoff. Inside were 4 astronauts. Commander Reed Wiseman, a veteran NASA astronaut with deep experience on the International Space Station. Pilot Victor Glover, a former naval aviator making his second spaceflight. Mission specialist Christina Koch, who holds the record for the longest single spaceflight by a woman. And Canadian Space Agency astronaut Jeremy Hansen, the first Canadian to ever leave low Earth orbit. That last fact matters more than it sounds. Every human being who had traveled beyond Earth's protective magnetosphere before this mission was American. 42 years after the last Apollo astronaut left the moon's orbit, humanity expanded that circle. But the crew composition wasn't symbolic window dressing. Each astronaut was selected for specific technical roles critical to the mission's primary objective, not landing, but testing. Here's what most coverage gets wrong about Artemis II. This was not a lunar landing mission. It was never meant to be. And understanding what it actually was makes it far more significant. Artemis II was a crewed test flight, a 10-day mission designed to push the Orion spacecraft and its life support systems to their absolute limits with humans inside. The trajectory was a hybrid free return path, taking the crew on a loop around the far side of the moon before slingshotting back toward Earth. At its farthest point, the crew traveled approximately 6,400 miles beyond the lunar far side, making them the humans who have traveled farthest from Earth in all of history, surpassing the record set by Apollo 13 inches 1,970. Think about what that means. Apollo 13's record was set during a life-threatening emergency. Artemis II broke it intentionally, with a fully functional spacecraft. The mission had 4 core objectives. First, verify that Orion's life support system works correctly for a crew of 4 across 10 days in deep space. Second, test the navigation and communication systems beyond low Earth orbit. Third, evaluate crew performance under the psychological and physiological stress of cislunar space. Fourth, gather thermal data on how Orion's heat shield behaves after exposure to the deep space radiation environment before the actual high-speed lunar return entry of Artemis III. Every single one of those objectives was mission critical for a landing. You cannot put humans on the moon's surface without first knowing your spacecraft can keep them alive during transit. Beyond the moon, the rules of space change. Inside low Earth orbit, astronauts on the International Space Station are partially protected by Earth's magnetic field. It's not perfect. Protection solar flares still pose risks, but the magnetosphere absorbs the most dangerous particle radiation. The moment Orion crossed beyond that boundary, the 4 crew members entered an environment humans had barely touched since Apollo. Galactic cosmic rays, high-energy particles originating from outside our solar system, travel through deep space constantly. They pass through spacecraft walls. They pass through the human body, and unlike the radiation exposure in low Earth orbit, there is no Earth-based magnetic shield to deflect them. The Artemis II crew wore personal dosimeters throughout the mission. Every hour of exposure was logged. Combined with data from the uncrewed Artemis I mission, which flew sensors specifically designed to measure radiation in the seats where humans would later sit, NASA now has the most detailed radiation exposure dataset for cislunar space ever assembled. This data directly feeds into the design requirements for Artemis III, Artemis IV, and ultimately, the architecture for any crewed Mars mission. Because the journey to Mars will take 6 to 9 months each way, entirely outside Earth's magnetic protection. What the Artemis II crew experienced in 10 days, Mars astronauts will experience for over a year. On day 4 of the mission, Orion crossed behind the lunar far side. For approximately 34 minutes, all communication with Earth was severed. No radio signal can pass through the moon. Mission control in Houston went silent. 4 human beings were completely alone, farther from home than any humans in history, out of contact, on the far side of a world with no atmosphere, no rescue mission possible. This is called loss of signal. It happened to Apollo crews too, but never with this many people, never this far out, and never with this much writing on what happened when the signal came back. Inside Orion, the crew continued their checklist, monitoring systems, logging observations, performing exactly the tasks that had been rehearsed hundreds of times in simulation. When Orion emerged from behind the moon and the signal reconnected, flight controllers received telemetry confirming every system was nominal. What the crew saw during those 34 minutes, a view of the lunar far side from 6,400 miles beyond it, with Earth a small blue sphere in the blackness ahead, is something no human had witnessed from that perspective since Apollo 17 inches December 1972. The most technically critical part of Artemis II wasn't the trajectory. It was the air. Orion's Environmental Control and Life Support System, ECLSS, had to maintain breathable atmosphere, correct temperature, humidity, and carbon dioxide levels for 4 people across 10 days of deep space exposure. This is a fundamentally harder problem than it sounds. On the ISS, life support anomalies can be addressed with resupply missions, spare parts, and a large volume of habitable space. Orion has none of those luxuries. The crew module is roughly the volume of a large SUV interior. 4 people living in that space for 10 days generate significant CO2, moisture, and heat. The ECLSS performance data from Artemis II gave NASA engineers real-world validation they could not get from ground testing. Atmospheric simulations on Earth cannot replicate the radiation environment, the microgravity fluid dynamics, or the exact thermal cycling of deep space. Every reading that came back confirmed the system was functioning within acceptable parameters. But there was one moment. On mission day 6, telemetry indicated an anomalous reading in one of Orion's environmental monitoring sensors. Flight controllers flagged it. Engineers pulled the data. For a window of time, there was genuine uncertainty about whether the reading represented an actual atmospheric issue or a sensor calibration error. The crew was informed. Protocols were reviewed. Contingency timelines were evaluated. Within hours, the engineering team confirmed it was a sensor issue, not a life support failure. The atmosphere inside Orion remained within all acceptable ranges throughout. But that moment illustrated something important about deep space crewed missions that simulations cannot fully capture. The cognitive and physiological impact on a crew when a potential emergency is flagged while you are days away from any possibility of early return. The crew's response, calm, methodical, procedure-driven, was itself data. Human performance under genuine deep space stress conditions. That data feeds directly into crew training protocols for Artemis III and beyond. On day 10, Orion performed its deorbit burn and began the journey home. Re-entry from a lunar return trajectory is fundamentally different from ISS crew returns. The Soyuz capsule, or SpaceX Crew Dragon, returning from low Earth orbit, enters the atmosphere at approximately 17,500 miles per hour. Orion, returning from the moon, hits the atmosphere at close to 25,000 miles per hour. At that speed, the heat shield reaches temperatures approaching 5,000 degrees Fahrenheit, nearly half the surface temperature of the Sunday. The Artemis II heat shield had been exposed to deep space radiation for 10 full days before re-entry. Understanding how that radiation exposure affects the ablative material performance was a secondary but critical data point for the mission. Orion splashed down in the Pacific Ocean. Recovery teams from USS San Diego retrieved the crew. All 4 astronauts were healthy. Here is the part that changes the conversation about space exploration entirely. Before Artemis II, NASA had the hardware. They had the rocket. They had the capsule. They had the trajectory math. What they did not have, what no space agency on Earth had possessed in 50 years, was verified, real-world data on how human beings and human spacecraft actually perform in the cislunar environment. Artemis II closed that gap. The radiation dosimetry data, the life support performance data, the crew physiological data, the navigation system, validation. These aren't just checkboxes on a mission report. They are the foundation that makes a moon landing possible. And here is the part most people aren't talking about. The data from Artemis II doesn't just apply to the moon. The cislunar radiation environment is the closest analog available for a Mars transit. The life support performance under those conditions is directly applicable to long-duration deep space missions. The crew performance data under genuine isolation and communication delay is the starting dataset for understanding how humans will function on a 7-month journey to Mars. Artemis II wasn't the mission that got humanity back to the moon. It was the mission that proved humanity is ready to go much farther. The moon is 239,000 miles away. Mars, at its closest, is 140 times farther than that. Artemis II crossed 250,000 miles of deep space with 4 human beings, brought them home safely, and handed the next generation of mission planners the most complete dataset on human deep space capability ever assembled. The next step lands, and the step after that doesn't stop at the moon.